Okay, guys, let's get started. So we are at the very end of the semester, as you know. Go to the virtual machine. All right, so we're going to log in. Okay. All right, so we just have today and then Tuesday, right? Next week is Thanksgiving week, so it's a short week. And then after that is presentations. So hopefully you guys are working on your project. We've already talked about it. Everyone has picked a topic, has a group. You need to present. That's 10% of your grade, I think. So don't forget to do that. So yeah, so the last lecture, today I'm just gonna wrap up, like I almost finished the malware detection thing. So I'll wrap that up and then we're gonna start our last topic, which will be ideas of Bitcoin and blockchain, right? So kind of wrap that up. Very interesting. So this last part of the semester, as you have seen, is applications of cryptography, right? So beyond what we've been doing, SSL and TLS, we've been looking at all semester. That would be like the main application that we've been looking at, right? Overall, HTTPS and everything that goes with that, all the primitives. We've also seen that we can use cryptography for malware detection. We can use cryptography for defense of denial of service attacks with the SYN cookies. So remember, those are questions on the exam that I'll probably ask. And then the final application that we're all familiar with is Bitcoin and blockchain and what that is, basically. So I'll go over that. I have a Jupyter notebook for that one. So I'll start that today and I'll finish it on Tuesday. That's kind of, and I usually have like one slide set of slides that I wrap up the semester. So, but this is the last topic, okay? There won't be any homework on this Bitcoin or blockchain. I just want you to focus on the project at this point, finishing up any other homeworks you have, but it should be interesting, right? It should be an interesting discussion. Okay, so I have my the virtual machine here. So just really quick, I mean, we had almost finished it, but I guess I want to stress the malware detection example. So I'm going to navigate to the desktop. Right, and you guys have this code. What is it? Anti-malware, I guess. Yeah, Cracklin, right? So we were doing this, and I showed you, obviously we needed to have a computer virus. Okay, that was the virus. Did we not do the scanner? Oh, we did.
We did.
Huh?
We did.
We did, right? Where is it? Oh, okay. I see what I didn't go into this semester's folder. Sorry about that. All right, so 315. There we go. Right. Yeah, so it would be in malware. Okay, more familiar. All right, here we are. So these are all the files. We were looking at the Cracklin computer virus, and then we had the virus scanner, which is what we were doing. So I think we were almost done with it. So I'll just, oops. What? Yeah, did I delete this thing? Cracklin file. It would be that virus scanner, I'm pretty sure.
Might have left it open, like narrowed it, then didn't close it properly.
Yeah. That might have happened. Oh no, there it is. Huh. So we do have it. All right, so clear. Not sure what's going on with this thing, but I'm going to CP this virus, virus, either two. All right. Yeah, yeah, so that's strange. And then dot py. Do y on it, so just it's like not properly finished, you think? Okay. Let's try it again. Now there it is. Thank you. Yeah. All right. Great. Let me do that the same. Let's open the other one. Scanner two. Okay, this one's opening. All right. So yeah, so a lot of problems, and it was pretty straightforward. We were running it and we had the hashes, right? If you remember, we took all the files, we calculated the hashes, right, with get hash. So we can run it. And we have the list of hashes. So basically now you would just need to have a database of these hashes that are actual malware. And then when you get all of these, you compare. If you have a match, basically you've detected a computer virus. Does that make sense, guys? So we were basically done with this, and it was at the end of class. So do you guys have any questions on this example? No questions? Make sense? Yeah. So this is the simplest case of getting, and so it's another example of using, as I said, cryptography for malware detection, denial of service attack, and now we're going to look at crypto, the idea of blockchain and what that is, right? So now it nicely uses pretty much a lot of the concepts that we've talked about all semester, okay? So we'll begin this discussion now. All right, so I'm going to exit out of here. Okay, and I'm going to create a new folder. I'm going to call it crypto and blockchain. Okay, and actually for this one, I'm not going to run it here. I'm going to run it in my, well, actually, yeah, I'm going to run it in my Jupyter notebook instead, just to keep it more. Do you guys know how to use Jupyter notebooks? Do all of you know how to use Jupyter notebooks and have Jupyter notebooks you can follow along? Nope. Okay. Um, I guess, yeah, I can run it here. It's fine. All right. So we'll just have to do a lot of print statements. So let's do that. ls-l ADIR. Yeah, crypto. Kind of makes sense. I forgot about that. All right. Yeah, so there's the folder. Here. CD into crypto. Here we are. So I'm just going to create a simple script here. Then let's call it, what is this really? At the end of the day, this is like, a wallet. Let's call it a crypto wallet. Crypto wallet. Right. And that's because I think that's like the best way to understand this idea. It's almost like a bank. And what do you have? Let's say you guys go to a bank. What do you usually have in a bank? A bank account, right? That's it. So this is like the honestly the concept to understand. And by the way, there's Ethereum, blockchain is just the original one, right? And people can just implement their own blockchains and things like that. And two popular ones are, so I think Solana, Ethereum, obviously Bitcoin, but there's many, right? It's like many, many, many others. So people just create their own. But essentially they're like a thing, a network of computers, right? And everybody has an identity. And you guys should understand if you think cryptography, identity, okay, public, private keys, all that starts to come into play. And at the end of the day, what you get is a type of an account. And you can call that account a wallet. And so basically that account will get what? Bitcoin, right? So there's going to be Bitcoin. And so then there's another wallet, another account. And what do? You're going to move some funds from one wallet to the other wallet. But that transaction is recorded in a thing called a blockchain, a block, right? And so that those are the general concepts, okay, of crypto. And so one, I think for me, one good way of understanding this is start with your account number and go from there. All right. And so that we're going to go through some commands, okay, and just kind of print out the things that are happening to establish the wallet, to establish the identity. And along the way, I'll talk about some of the things. Okay. So let's create this Jupyter. I think this should run fine on the script. So I'm just going to say crypto. So Bitcoin. Again, this is just based on like the most original implementation, the simplest thing. These are active companies that are constantly developing things to improve, provide services, right? You know, they want people to use their coin, right? So that then people have to go buy that coin with actual dollars and then use them like in games and things like that. All right, so let's leave this here. So I'll show you, I prepared a notebook. So it's here. So you can go to the cryptography repo of the course, right? And then you can go to this folder, Bitcoin blockchain. So everything I'm going to say today is here in this Jupyter notebook, Bitcoin chain idea. So this is basically the whole thing. It's pretty extensive. And I don't expect you to like, you know, to even care so much about what's going on inside, but it is built from scratch, which is kind of nice. So all this code is a very simple Bitcoin blockchain implementation from scratch, like almost no libraries, except like, you know, math or something like that. And it's a lot of the concepts that you understand. Public and private key encryption, hashing. Hashing is big. Also, elliptic curves. And you guys remember your elliptic curves, right? I almost want to say that to me, Bitcoin is really an elliptic curve. That's almost like you want to, you know, you can think of it as whenever you create a Facebook, right? That's a universe of Facebook, or you create TikTok, that's a universe. So Bitcoin is its own universe and it's governed by the laws of physics of the curve, if that makes sense, because a lot of the things are being derived from the curve, the elliptic curve. And we've already talked about this in one lecture, right? So you should go back to that lecture to get an idea. But that's kind of how you should think about it. All right, so I'll go over. I have a lot of notes. There's a lot of detail in how it works. So I'll go pretty slowly and just talk about it. So Bitcoin, some key concepts, you know, so at the end of the day, maybe we still need to determine how does Bitcoin represent value, right? Is there value in it? Okay. So as an investment, are you actually getting value and what is it? Okay. So let's take a look at, so I'm going to just copy some code from here just to make sure that this will run. So I obviously tested this on my Jupyter notebook, but I forgot to test it like this. So let's see. Yeah, all right, so it worked. All right. Yeah, so just some very simple libraries for class definitions and things like that. Don't worry, as I said, of the code so much. You know, this implements like the hashing, you know, from scratch and things like that. All right, so let's kind of have a discussion, right? So as I said, the key thing is we want this account, right? This account number, which is basically just going to be like a hash also as a unique value associated with your private and public key thing. So when you do your transaction, you're going to say like, this is my account. And you're also going to, once you finish that transaction, sign it with your private key, for instance, right? And that's like a digital signature that's happening. You see that? So it's basically that process. So first, we want to generate a brand new cryptographic identity, which is just a private and public key pair, right? And you guys understand that concept, right? That we've used that for identity. Again, this, newer versions of Bitcoin or other cryptocurrencies, blockchains can have different approaches. We have seen that, but this is this discussion. Bitcoin uses the elliptic curve cryptography, which we have discussed already, which means there's an elliptic curve associated, instead of something more common like RSA for the secure transactions. And the curve that is used for Bitcoin is this one. If you guys remember, I had said that these curves have been studied, right? Have been studied. And there's the NIST that provides some recommended elliptic curves to use. But I believe all of these were created by the NSA. So some people are afraid that they could have backdoors and things like that. So then they use other ones, not recommended. Okay. So NIST publishes recommendations on which curves to use, but people prefer to use other curves like this one that are less likely to have backdoors built into them. All right, an elliptic curve takes only 3 integers to define. So we have done this before. If you guys remember, we looked at functions that look like that. Do you remember we did this? And basically, what was the idea with the elliptic curve, right? We said it's a function. We did like a graphical representation of it, and then we would pick points. Do you guys remember that? So we have a point, and then we define operations like add, multiply, etc. But these were geometric not like common addition, but instead special geometric additions that you take a point and another point on the curve, you add them, and it results in yet another point on the curve. And then we would use those things kind of to start deriving things, okay? So that's the idea. So this is an elliptic curve, right? And points on the curve will satisfy this graph. So for instance, we can instantiate this class. Actually, I think I'm going to open this in my here. Let me open this here. Might be easier. Okay. Paste. All right, so we instantiate here just the variables of the curve itself, okay? And we're going to try some points just to see if they are on the curve or not. Kind of the first idea. And then from there, we're going to just use that information to create an identity. And then we're going to use that information to create an account. And that's it. Once you do those things, boom, you're on the blockchain. Do you see what I'm saying? Because you have that account, and the way that to control that is because everything is derived from the curve that you have chosen. That's it. All right, so created this class. Let's go to this one over here. These are some parameters of the curve. Okay. All right, so this just defines for the curve P, A, and B. And this defines the Bitcoin curve, which is going to be the p-value and A and B. These are written like in hexadecimal, but you can see they're equivalent to 0 and 7 in this case. Okay, so we have that. Right. We're going to have a generator point, which is just a starting point on the curve's cycle, all right, which is used to kick off like a random walk around the curve. And this would be a publicly known and agreed upon constant. Okay, so we can go ahead and define that class. Okay, here we go. Okay. And then we go back. Here we have the bit, a definition of G with some values, okay? And then we're going to have the actual function. So we can go here, paste. So that's a point in the curve. Let's run this just to make sure it runs without issues. Okay, no errors. That's good. Okay. So now, as I said, we're defining the classes, basically a whole bunch of points, right? A set of starting points, set of parameters, A and B, and then we just need to establish our function over here, right? So if we copy this one, we can verify that the generator point is indeed on the curve, and this is the curve in this case. Does that make sense, guys? So that's your elliptic curve that you're using to generate the values that you're going to use to define your world of Bitcoin. It's like you're building this world, I would say, on this curve. All right, so we can copy this one over here. Copy it. Paste. All right, so generator is on the curve. This is the function. As you can see, G has an X and a Y that you can see, right? This is the dot Y dot X minus 7. And we're just going to check to see that it's equal to 0. If it's equal to 0, that means it should be on the curve. Does that make sense, guys? So that's basically all we're doing. So Control X, Y. This should return true. So that point is on the curve. It's a good point to use. And now from here, we can start deriving our identity, our count, and from there, we do transactions, okay? All right, so we're going to do that. Open the Jupyter, or sorry, the Python script. So now we can try some other totally random point, which hopefully will not be on the curve. So we would not want to use that one. Paste. All right, so you can see it's just some random value. Again, we do the same thing to check if it's on the curve, the elliptic curve. False. There you go. So there's got to be a specific number that fits, the definition of being on the curve, which translates to being secure, versus a totally random one, which is not on the curve, we should not use. Right? So that's a check, an assertion that you can do. All right, now that we've established that, we can proceed a generator over a curve. Okay, so we're going to have a way of generating. And from there, we're going to generate a value, right? Like a large integer. So I'm going to go over here, paste. All right, this is a point, and the order of the generating points. So, how many, a value basically that we're gonna perform an operation. Okay, so I create this. The Bitcoin generator. Okay. Paste. So this is still the point, just a whole bunch of classes. Okay. And here. So we're going to generate basically, you can see down here, this number, okay, from all of this, from the curve. The private key, or you can call it a secret key, is simply a random integer that satisfies this, right? So something like that. And n is the order of g, right? So to perform some kind of operation. So we should be able to create the secret key. All right, so secret key is here, right? We give it some text, right? So you can, provide some text here. This is how we will initialize. So basically, there is a password that's, that you're supposed to remember with Bitcoin, right? So there's like a whole bunch, I think like the rule is like 20 words or something like that, and that's your password. And from there, you kind of hash. That's the thing that you remember and the thing you should not lose. But in this case, this is the example. If someone else has this, they'll break your whole Bitcoin. Do you see what I'm saying? That it's like encryption, right? So there's some original source, and from here we're generating all the values. But having this translates to being the password that you plug in there. From there, then you would generate the same number. They'll take you, because if you have that public and private key, it's your account. So you lose your Bitcoin. Does that make sense, guys? All right, so here we have, then we're going to print the secret key. Notice secret key, you just take this value, okay, some kind of random, okay, or based on a password. So over here. All right, so here we have our initial number, basically. Okay. So this is our secret key derived from some password or text that we provided. It is a simple integer, but anyone who knows it can control all of the funds you own on your Bitcoin blockchain. Right. And as I said, I believe now it's like 20 words. That's your password that you should remember. Okay. So as you can see here, in the simplest, most common vanilla use of Bitcoin, it is the single password that controls your account. Can skip that. So now from here, so you go from password to generated a random integer. And then from there, we are now going to generate the public key, which is where things, start. Okay. This, of course, is going to start using the elliptic curve. These should be all concepts that are familiar to you. So the public key is the point on the curve that results from adding the generator point to itself secret key times. Do you see that? So that's kind of, if you remember what I said, you define the curve, you have a starting point, you do some operations, and at the end of the day, you arrive at another point on the curve, and that starts to act as your public key and so on to establish an identity. Okay, we haven't created the account yet, right? Well, we haven't created the wallet, but it's all being derived from here. So the public key is the point on the curve that results from adding the generator point to itself secret key times. So for instance, if we have a public key, so secret key times G, basically, right? So something like that. So some operation. Notice again that both add and the times symbol are very special, right? So they're defined only in the curve, like the geometric operations. The secret key is an integer, but the generator point is an X and Y tuple that is a point on the curve, resulting in an X and Y tuple public key as well. Again, a point on the curve. Does that make sense, guys? Any questions so far? All right. All right, and this is where you do the operations. And as I've said many times, it has a very specific definition and a geometric interpretation. All right, so now let's go ahead. So these functions, guys, we've already mentioned them, extended Euclidean algorithm, the in function that was elliptic curve additions and everything. We're just going to use these as a library, okay? So, you guys, however, if you want, you can go in there and like verify or learn more about it. But I'm just trying to create from some passwords, a number, got an integer, right? And I want to establish my identity. I'm going to copy this one. Yeah. I'm going to paste these in here. Okay, so I have several functions that I'm going to be using to do calculations, etc. This is going to, what is that? Let me just change this. Yeah. All right. So these are the functions. This one doesn't seem to have any issues. There's this other function. And then here, basically, we're going to use that elliptic curve addition to create a point, basically, the resulting point. So you're seeing, in fact, operations on the elliptic curve, basically. So that point, let's see if it runs without issues. Okay, so far so good. That we have now a point, right? Kind of established. All right, so the important thing to note is that everything is just a bunch of adds and multiplies over tuples of X and Y. Why X and Y? Because they're just points on the curve, and we have these definitions of adds and multiplies, and some modulo operation in there. Okay, so now we're going to use it by generating some trivial private and public key pairs, okay? And remember, just like with RSA, where we created public and private key from the P and Q, and that was pretty secure, now we're doing kind of the same thing, but through the elliptic curve approach. And these actually, by definition, can be smaller, so they don't have to be as big as the RSA keys. So let's do a few examples. All right, so I'll just kind of grab them individually. Okay. Copy. Paste. So if our secret key was the integer 1, then our public key would just be G, okay? The point G, so you can see we initialize these two. So we're going to print the secret key and then verify the public key is on the curve, basically, which is something that we have done before. So let's try that. Verify it's true, right? So, and your public key, as you can see, just given 1, notice there's your pairs, right, of the public key, okay? So, because it's an X and a Y. Does that make sense, guys? So we're just generating from the curve public and our public key here, basically made up of a tuple of X and Y. All right. So this is just examples of trying out numbers. So let's go ahead and try another one. Okay. So here, right? And I'll guess I can just I'll skip. All of these are on the curve, so I'll just skip to this last one. Okay. Thanks. All right. So if our secret number was 3, then basically we have G plus G plus G as the operation, right? So we can you can see it's being done, and then PK is printed to make sure it is on the curve, and it is on the curve, and we generate the numbers here. Okay, so that's essentially just looking at elliptic curves in action, right? You start with a point, you define the operations, and now we start getting things. Okay. And from here, we're going to use this, and this is establishing identity, remember, right? From password to a random integer to using that to generate this through the curve, and from here to our wallet, and that's it, secure. All right, so let's go ahead, keep going. I'm going to open up my Nano here. Gonna add a new line. All right, so now I'm gonna go over here. So I have these. So these are, this is an algorithm that is more efficient for processing to speed up, these computations. Okay, and then just, to perform some operations. So let's add this in here. Copy. All right, so this double and add algorithm speeds up processing. Class for convenience here. And then, yeah, so this is just corroborating that G plus G is going to be 2 times G and so on. I'm going to get rid of this true. Those should come out as true. Okay. And we should be able to use that now. Okay, so let's go back to the Jupyter Notebook. All right. So now we have our secret key times G, public key, and this should be with the actual secret key. We'll print the secret key. So let's copy this. Copy. Paste. Okay, so I'm going to print secret key. All right. Then we perform the operation secret key times G. That gives us public key. And then we can print that out and verify that it is on the curve, basically, right? So the same idea. The previous ones were examples. This should be the actual operation. Yeah, so this was the 222, if I remember, that was obtained from the password initially, right? And so fine, it's on the curve, and we've defined our value, which is a tuple of x. Okay, that's the security of it. Okay, so now go back to the notebook. As I said, remember, where am I going with this? I want to create that wallet, right? The wallet is just an account number type of thing that is going to be associated with my Bitcoin, my actual Bitcoin money. Remember that Bitcoin in blockchain, I think there's only 3.1 million Bitcoin, right? There's not more than that. You cannot mint new Bitcoin, right? So the key thing that this thing does is that it creates scarcity. Do you see what I'm saying? That's if you could print Bitcoin, then it has no value, right? Let's just make a million new Bitcoin. No value. So the thing is they create scarcity by just creating this whole framework, and they can only have 3.1 million ever, I believe. Okay. And so that's kind of the idea. Otherwise, people would get angry because the value of their Bitcoin would go down if you're all of a sudden diluting the thing. All right. So now let's go ahead here. And we printed this. So with the public key pair, we now generated our crypto identity, basically. All right. So this should be our crypto identity. And now it's time to derive the associated Bitcoin wallet address. All right. So this is the key. We did all of this to establish our identity. And now to basically establish the wallet. The wallet address is not just the public key itself, but it can be deterministically derived from it. Okay. And has a few extra goodies such as an embedded checksum, etc., things like that. Before we can generate the address, though, we need to define some hash functions. So as you can see, here comes the hashing. So from this public key, we're going to hash, and then we're going to have a hash number to get to our wallet, basically. The wallet address is not just the public itself, but it's deterministically derived from it. So we need to define a hash function. Bitcoin uses the ubiquitous SHA-256 or another one called RIPE MD160. And here, just for academic purposes, it's the SHA-256 and implementation in pure Python. Probably never use this, right? So you should probably use libraries. But again, if you guys have an interest in understanding how SHA-256 works, there it is, right? It's pretty big. I'm not going to cover, we didn't cover this in class. It's a lot. I think it's basically like XOR and a whole bunch of bit shifting and things like that. All right. But I encourage you to read through it, and you can read all these documents from the NIST on everything. I'll just copy it and run and use it basically. All right. So this is a pretty long one. So hopefully this will work out. Okay, there it is. And it should return oh yeah. So yeah, let's just copy the function first. Go over here. All right. Paste. Okay, so hopefully it copied everything with the indentation properly. All right, so now we're going to use that function to generate from our public key our hash value, and so we can get to our wallet. All right, so I'm going to go back to the code here, copy these ones. All right, so basically we use gen SHA-256. All right, that's SHA-256. So, okay, and print the size of it basically. All right, it generated a hash value. Okay. And it says that number of bytes is 256, it's 32. So let's go back here. Let's take a look. Okay. Let's go back to the Jupyter. All right, so this is a empty hash. Okay, so we had nothing as an input to it. Okay, this is the other function, get rip one. Okay. And then encoding, I'm just trying to jump ahead. This should summarize everything to the address, right? So all right, let's see. Okay. That's just a little, there's a lot here. So. All right, so we initialize our hash function. So let's kind of think about this one. So we have this SHA-256. When we call it, I know, if you notice, we're using it. We instantiate it. We use it with nothing. So this is an empty hash, basically. You can see this function. It looks pretty difficult, but we've discussed this in class. Is basically, as I said, similar to the XOR operation, bit shifting, basically. SHA-256 takes some bytes message that is to be hash. It's got some padding, breaks it into chunk. This is the algorithm, right? And passes these chunks into what can be best described as a fancy bit mixer, which we've done several times this semester, contains bit shifts and binary operations and so on. It creates, as you know, a fixed size, random looking short digest, basically. So this is just the basic definition. And as you guys know, it should be impossible to break it. Bitcoin uses SHA-256 everywhere to create hashes, and it is the core element in Bitcoin's proof of work concept. So this is going to be used extensively, for instance, in the miners, also the mining, where it takes a block with transactions and it hashes that. You see that? So that when you make, let's say you get some Bitcoin from A to B, that's a transaction. You have to add that to the ledger, which is the block, and that gets hashed. And so that way it can't be changed anymore. No one can go in and say, no, it was 2 instead of 3 Bitcoin, right? Because there's a hash of it. You guys see that? So that's what this is saying. Bitcoin uses SHA-256 everywhere to create hashes. Remember, what is that? That's the principle of integrity, basically. And integrity could be thought of as this idea of proof of work. Okay. Okay, and then yeah, so this is just making comments on performance. Before we can generate our address, which if you remember, it's still what we're trying to do. We've only have a password. We have some public and private keys thanks to elliptic curves. We have now hashing functions, right? And we're still trying to get to that wallet. All right. So before we can generate our address, we also need the ripe MD160 hash function. So this is another hashing algorithm. Again, pretty complex, but in essence, bit shifting and things like that. Similar to the XOR, as you can see, is quite the function. So usually these would be libraries, etc. But for now, you can see them and view them. So let's copy it. Okay, so there we go. Copy. So I'm going to take that in. So now I'm adding a second hashing function. Okay, that should be that one. Hopefully everything copied correctly. All right, there's the function. So now we're going to try to use it. Something with it. Let's add a line here. Okay. So now let's go back and we can copy these. This is a test, basically. We're going to hash something with that function. So once again, we grab the function, get, this one, right? And then here we invoke ripe MD 160, give it some text. This time, just instead of blank, it's just hello, this is a test. And we print out the hex digest and it should print out the length of it, right? Just testing the functionality. So let's go ahead and do that. Similar to the previous example. And you can see this one is 20. And there's the hash of it using that function, basically. Just hashing. All right. Keep going. Okay, so now pretty long code. All right. So now let's get to, all right. So it's again, and even though the code is pretty extensive, a type of a bit scrambler, a lot of binary operations, right? So now hopefully we are starting to get ready to get to our Bitcoin address, right? Which is the thing that we want so that we operate on, we can have basically monies in there. This is going to have some additional subclasses. With the, one of them is going to be the public key, which is again, just a point on the curve. Okay. And now it has an additional interpretation of a Bitcoin public key in this case. We're going to need also some methods of encoding and decoding the key into bytes for communication in the Bitcoin protocol. This is another thing that's kind of difficult to understand, but actually it makes a little bit of sense. So for instance, I'll tell you this. So the encoding is not going to be like a regular hex encoding exactly. Why? This is important, right? This is your money. You could take $100,000 of, you could sell your house, take that cash, convert it into Bitcoin, right? It's kind of scary. So you don't want to make the mistake of thinking that this is a 0 when it's an O. Do you see what I'm saying? So that's what this is for, is to avoid those kinds of letters that look a little bit the same. So they created a new type of an encoding for that. So that's what this is alluding to, okay? But now has some additional semantics. And then we have some methods of encoding and decoding the key into bytes for communication in the Bitcoin protocol. All right? Yeah, so we've talked about this. It's going to have, this class is the public key with encoding, the address, and so on. So all the computations. And you can see here, it's going to take, these functions. So we'll see that in a sec. So let's go ahead and copy this one. Copy. Paste. All right. So now So we are now ready to take this class. Yeah, so that we also have this B58 encoding function. And as I said, this is just Bitcoin specific encoding of bytes that uses base 58 of characters of the alphabet that are very unambiguous. For example, it does not use O and 0 because you could confuse them because they are easy to mess up on paper and you could lose your money that way. So we have to take our Bitcoin address, which is 25 bytes in raw form, and convert it to base 58 and print out those characters. So that's basically what that's for. And then this just gets into some of the details of it. And it's got several things in there for more security, but let's just add this function here. So it's an additional layer of encoding, basically. All of this, we still haven't gotten to the wallet. All right, let's run this just to make sure that it's good. Okay, everything seems fine. Go back to the Python script. All right. That's why I kind of wanted to do this in the Jupyter notebook, but I figure I shouldn't. All right, here we are. So now, so we covered this. So finally, let's print out our address, right? So if you notice, we create the class public key. We give it, so notice this is the key thing, right? So we had calculated the public key. That goes in, it just says from point. Remember, it's a point. What point? A point from the elliptic curve, right? It's added into this class public key, and then from it, one of the functions just generates the address, right? And so now we have an address basically, and that is in fact your wallet, right? So this is just an example, assuming your secret key is 1. So then secret key times G gives you public key, and that's what goes in there basically, right? So that would be an address for the secret key number 1, which is not the actual number you're using, but it should just give you an idea. So let's do this first. Paste. Okay. So we have that one. And let's also add the other one with just 1. Okay. So this one, I need to print it because it's a Jupyter notebook, so I didn't have that. You see that? That's it. So that basically should be, I think, the wallet now. So let's go ahead and print both of those out. And there you go. That's the whole process for creating. So where does this exist? It only exists in the Bitcoin curve. It was derived from all the operations that only exist on that curve. And now this is what you can start using when you do transactions. You'll send, it's like there's a communication protocol. So you'll say, I, MNN, blah, 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 send 20 Bitcoin that I have to this other person. Do you see that? And so that's it. So then somewhat that gets like broadcasted via, this is like a network part now, which, we're not going to cover that, but you would send that in the network. People would receive that. And what can they do? how do they know that they should pay attention to you? Because of this value. Do you see that's unique? So they're going to say, oh, that's in the, yeah, that came from the Bitcoin curve. That's in the Bitcoin. That's an account. I can actually look it up. There's this much Bitcoin and so on. You see that? And then at the end of the day, it's going to be a whole bunch. We have to do transactions also. So this is just at this point, creating the account. And then we need to get some Bitcoin in there, right? Some monetary thing. And usually this will be handled by you going to a company and giving cash in exchange for Coinbase, I think, right? Something like that. You give money and they'll put Bitcoin into your account. And so then now you have to do the transaction. Do you guys understand that? Because you can't make Bitcoin with cryptography, right? Remember, that's a scarce resource. So that has to be put in there. But you can earn Bitcoin. Like miners earn Bitcoin. How do they earn Bitcoin? By taking transactions and hashing them. Because that provides integrity, right? They're hashing. And so they'll maybe have a block that they're in charge of, and then a new transaction comes in. But do they want this transaction? How much Bitcoin are you going to pay me? 2 Bitcoin, 0.001 Bitcoin. And then comes in another transaction. No, I'll pay you 0.05 Bitcoin. Okay. You add it to your ledger and then now hash that. And that's what miners do. Do you guys understand the computing power, right? But they provide, but actually it's not just the computing power, it's someone else verified. Do you see what I'm saying? And provided. So that's how it works. So you don't need a centralized organization. It's actually all of you who are providing the verification. Any questions so far, guys? Is this making sense? So we're not going to finish this today because there's quite a lot, right? So we're getting right now, my goal was to just get to the account, right? Then there's how to get coin in there. Then once you have coin in there, the protocol of the transaction, right? Which is, it's got more of a, like a language. It almost has like its own programming language, but it's just short and mostly like just hex, basically. And then the ledger and mining that to provide proof of concept. And that provides like the basic functionality of Bitcoin. Do you guys see that? Any questions? All right. So we're getting to a point where we have like a summary, right? So we've generated some accounts here basically. And the insight, if anything, is these accounts can only come from numbers of the elliptic curve defined to be the Bitcoin elliptic curve. That's it. That's like the magic of it. So Bitcoin lives on this elliptic curve in a sense. All right, so let's go ahead here. So I think we ran. So this was, this is the encoding. Excuse me. Then we did our address here. We did an example just using 1. Now, I don't have this part, but once the transaction is loaded in the ledger, there's like a website that Bitcoin can have, and you can Google like, okay, this is my wallet, how much money is in there. So we should be able to check in something like Blockchain Explorer, and we could check this address to see how many times it has transacted and the balance of it. So for instance, 0.02. So I don't have like an actual wallet number. This is just an example I'm using. But in essence, if I was starting to create transactions, right, and notifying people that I have this account, then basically it would appear in the ledger, and then some website probably run by Bitcoin would show information. So, there is that part. And I leave that to you guys to explore if you would like. All right, so anyone would just be able to spend your money if they know the secret key, right? So again, this is the critical thing that you should not lose those passwords or the key. So obviously the passwords generate the key, but if somebody also hacks your key, I mean, they don't need your password. They maybe can't reverse, but they could still do some transactions. And they could also use it to digitally sign transactions, as you guys already know how to do that. All right, so we're gonna kind of look at this summary. This is part 2, right? So this is something I wasn't planning on covering today, but let's just kind of drill down to this part because we still have one lecture on Tuesday. All right, so summary so far, right? So this is our summary. We were able to generate a crypto identity, public-private key, right? You guys are familiar with that. That consists of a secret, which was a random number that we only know. We generated this from our password, and a derived public key by jumping around the elliptic curve using scalar multiplication and generating points on the Bitcoin elliptic curve. So we've seen that, right? So we have that. We then also derive the associated Bitcoin address, which we can share with others to ask for money. And doing so involved the introduction of the 2 hash functions, SHA-256 and this other one, RIPE MD160. And so here are the 3 important quantities summarized and printed out again. So let's go ahead and do that. Pretty long. Still going. All right. So yeah, so this would be a whole bunch of files usually. All right. So I'm going to paste this in so you can see our first Bitcoin identity. We had our secret key from our passwords generated our public key, X and Y tuple from the elliptic curve. And from there, we derive our address, which lives in the curve in a sense, or from the curve, and that now can obtain Bitcoin. So let's go ahead and do that. And there you go. So our secret key was that 222 thing that came from some piece of text. Our public key is a tuple of a point XY from the curve. And then finally, our Bitcoin address is this one, MNN, right? Which is MNN, the first one over here. Does this make sense, guys? And that basically allows you now to have Bitcoin, but to have a wallet, but your wallet has 0 Bitcoin. So you have to now figure out how to get Bitcoin in. You have to pay cash for that. So let's go to so we finished this part. That was part 1 of our discussion. I wanted to go back one thing, a class that we created, right? There's one class that we did here, public key, that had a function called address. So this was just the encoding, this function. So I want to kind of drill down into this class a little bit. All right, so kind of get a feel for how it works. Okay, so the public key is just a point on the curve, but has some additional specific encoding and decoding functionality. So this is the encoding. And this basically is what I was looking for. So if you look here in code, it takes PKB. PKB is this, which takes X and Y. Do you guys see that? Right? So this is important. Self X and Y of the point itself. And so it just is concatenating them in a sense, right? Self X to bytes, self Y to bytes. See that? Becomes PKB. And then what is happening to PKB? Hash, double hash, right? So that's where that hashing part comes in. And that's the whole process. Think about it. That's your cryptography right there. This shows us, how to use elliptic curve in code, which we hadn't done before. And then ultimately it shows us that from that public password to secret key, the public key from the elliptic curve to those public keys being concatenated and being double hashed. That's the whole process. Like if I asked you in the exam, how do you create a Bitcoin wallet address? You just say that. Make sense? Any questions on that? Perfect. Excellent. All right. So that seems like it made sense. So we can keep going then a little bit. Let's just see. I guess I'll kind of look over everything that we have left. So we've done the part one, creating an identity. So you guys understand all of that. Now obtaining seed funds, right, to the Bitcoin process. So how do you get that actual currency? So that we can discuss that a little bit, but as I said, you have to create money, then or pay, sorry, not create money, pay cash and obtain Bitcoin. The price of one Bitcoin right now, it's $98,000, right? So obviously you don't buy one Bitcoin, but you buy like 0.0001 or something like that. All right. Then after that, this discussion, we'll talk about transactions. And this is the language of transactions, which is like a programming language in itself. And basically, you just have to very, very simple. This wallet, send this much Bitcoin to this other wallet in the Bitcoin space, right? And that's kind of the idea so that you can buy maybe from a game, specific shield or something you want, something like that. All right, so you use the transaction. Although nowadays, I think you can buy a Tesla with Bitcoin, right? That's what I heard, that a lot of companies are accepting it. So anyway, so that's one of the things. The transactions is a whole process basically of the commands, encoding them, creating a hex of it, signing it will be the next part. You have to sign your transaction, okay? And so this is the whole process of it. It'll end up with a digital signature, okay? And basically that should be it. Putting it all together, yeah. And then the mining part, that would be like the last component of it. All right, so that's kind of the overview. So let's go back. I guess we have a few minutes, so we'll wrap up today we've created the address. Now let's just briefly look at funds and everything, how to get some funds in there. And then from there, we'll continue this lecture next Tuesday and just wrap it up as a discussion. All right, so obtaining seed funds and then Bitcoin under the hood. The key thing now, it's going to be this idea of a transaction, okay? Which is a very simple moving of Bitcoin from one to the N. I believe when you have money in your wallet, you have to, probably because of the way cryptography works, you have to move all the money out, but you send it back to yourself in a sense. So if you think like, if you have, let's say you have Satoshi is like a 0.001 of a Bitcoin, let's say. So 100,000, right? So you have 100,000. 100,000 is one Bitcoin, but it's 100,000 Satoshis, right? Just to keep it simple. So then you have 1,000 Satoshis. Then what you will do is you will pay someone, I said 1,000, right? So 500 Satoshi, and the other Satoshi, the other 500 of the 1,000 go back to you. So that's kind of how it works. Do you see what I'm saying? So you have whatever you had, you send it all out, but part of it returns to you and the other part goes to the other account, right? So that's the basic mechanism. All right, so the goal here is going to be to send some Bitcoin from the address we generated, which was this MN, to some second wallet, right? So how do we get a second wallet? The same way we got a first wallet, right? You would repeat that whole process. And then now the transactions would be from one account like that to another account. So this basically just says, let's go ahead and create a second wallet. So now this is a good way of repeating the whole process, right? So kind of summarize what we did before, but we're just creating a second wallet. Bob and Alice. How about that? So one was Bob, the next one is Alice. All right, so let's go ahead and do that one. So should have that done. I can swipe down.
Control N.
Control N.
End.
Control End. Okay. Where's
Oh yeah, we're using a lot though.
Yep.
Oh.
Yeah. With my mouse. Oh, there you go. Thank you. All right, so we're there. So now we're just going to create a second wallet, okay? And basically the idea is to do transactions, okay? Paste. So repeating the process. So here, what is this? Your password, right? 20 words. Okay, creates the number. You can assert that it's a valid number. Then you take that secret times G. Remember, this is the operation, right? So this is a number, and then you multiply that times G. That gives you your public key. Okay, so now you go in this public key from point public key 2, and you get the address basically, and that gives you the new address. So here we're just going to print out the secret key, the public key, which is X and Y, and the address of the second wallet. Make sense? Any questions? All right, so I'm going to do this. And so this should be our second address, basically in Bitcoin. Okay. All right, so let's go back to the Jupyter. So our goal then would be in this example to send Bitcoin from this wallet to this wallet, basically. And unfortunately, because these identities have been generated initially, there is no Bitcoin in them, so they're basically zero, so there's nothing to send. So in this example, you have like this simulated for developers universe where you can just somehow in a database put some Bitcoin, but otherwise we would probably need to pay money and have the money appear, right? Have it be available. Available faucets to please request for some Bitcoin, basically, right? So, but you have to buy it, obviously. So you guys can look this up, for developers, there's all these resources. So you can Google testnet faucet, hitting the first link and asking a faucet to send some Bitcoin to our source address, right? A few minutes later, we can go to the blockchain explorer and see that we received coins, in this case, about this amount. So you don't actually have like Bitcoin like here, right? What you have is an account, and there's going to be a database that says that account has this much Bitcoin, basically. Do you guys understand that? Because that's how it works. So Now, one thing I don't know is like if somebody makes a transaction, send 20 Bitcoin, but they don't actually have it, right? Because you could create a transaction. You'll see later on Tuesday that you can create the transaction and say from this wallet, send, let's say, this amount. But I think what happens is once it gets to whoever's verifying, they're going to probably check your account and see if you have actually that Bitcoin. If not, they're just going to reject it. It doesn't go in the ledger. So effectively, nothing happened. Do you guys see how that would work? There is no, so there's, what I'm trying to say is there's not like you have 20 Bitcoin here. Do you guys understand what I'm trying to? Yeah. So there is no hash that somehow is Bitcoin. Instead, it's an account and you need, it's used as a record that you do have some Bitcoin in some database. Make sense? All right. So I think that's a lot for today. I'll let you guys, you can read through the Jupyter notebook. Okay. And then on Tuesday, we'll wrap up. It'll be the last lecture, kind of review this and just look at some of those, the idea of transactions, which again is the same thing. It's like a language, encoding it into just hex, signing it with your public and private key, and sending it to these people that will basically decide if they put it in the ledger, if it meets the conditions, and then they hash that for proof of concept. And that's it. That's essentially the whole process. Why is this useful? I think two things that I've seen. One is it creates scarcity, a scarce resource. There's only 3.1 million Bitcoin. So that you want to have that because there's only that many. And then the other thing is the decentralized idea that is no bank that has this, right? It's supposedly everyone, right, that decides to have a block and mine it and create hashes. That's how you cannot modify that transaction that takes place. Do you guys see what I'm saying? So essentially that's the 2 points where I see value in it. All right, but anyway, so let's this is a good stopping point. And then we will continue and wrap this up on Tuesday. All right, that's it.